This is homework 17 questions for homework 17. 1A says the absolute value of 2x minus 7 equals 5. So we've got our absolute value by itself on one side. We'll make our positive side 2x minus 7 equals 5. Our negative side 2x minus 7 equals negative 5. Add 7. 2x equals 12. Divide by 2. X equals 6. Our steps will be the same on the other side. We'll add 7. Divide by 2. X equals 1. So x equals 6 or x equals 1. B, the absolute value of 7 plus 7x equals 35. So our positive side would be 7 plus 7x equals 35, and our negative side would be 7 plus 7x equals negative 35. Subtract 7. 7x equals 28. Divide by 7. X equals 4. Or subtract 7. Steps will always be the same. 7x equals negative 42. Divide by 7. And x equals negative 6. Problem C. Problem C is just a little bit different because it has stuff outside our absolute value. We can see it says the absolute value and then minus 4 equals negative 2. So when there's stuff outside of our absolute value, we need to get rid of it first. So we're going to get rid of it by doing its inverse operation. Absolute value of n minus 1 equals 2. So now we have our positive side and our negative side. N minus 1 equals 2. Negative side, n minus 1 equals negative 2. Add 1 to both sides. N equals 3. Add 1. Or n equals, what is that, negative 1? D is the same type of problem. I'm not going to do another one of those. E is the same type of problem. F is a different problem. So we'll look at F. It says negative 2 times the absolute value of 9 plus 5x equals negative 22. So here, what do we have outside? We've got a negative 2, and that looks like kind of like the distributive property, right? Normally we'd think we might distribute this, but we're not, because we want to get rid of that. So what undoes multiplication? Division. So we're going to divide both sides by negative 2. So we get the absolute value of 9 plus 5x equals, what does that make? 11. Now we've got our positive and negative side, and it's just like all our other problems. So 9 plus 5x equals 11. And our negative side, 9 plus 5x equals negative 11. Subtract 9. 5x equals 2. Divide by 5. X equals 2/5. Subtract 9. 5x equals negative 20. Divide by 5. X equals negative 4. So x equals 2/5 or x equals negative 4. So that was F. G and H are very similar problems. Let's do H. H says negative 5 minus 3 times the absolute value of negative 4n plus 5 equals negative 32. So we want to get rid of that stuff on the outside. And the stuff on the outside, this negative 5 here, that's addition and subtraction, or subtraction. This negative 3, that's multiplication. So we've got subtraction and multiplication. We're going to undo the subtraction first. We're going to add 5 to both sides. Negative 3 times the absolute value of negative 4n plus 5 equals negative 27. Now, what undoes multiplying by negative 3? Dividing by negative 3. That gets those away. Simplifies to 1. So we've got the absolute value of negative 4n plus 5 equals 9. And now we should be able to do this problem, no problem. Negative 4n plus 5 equals 9, and negative 4n plus 5 equals negative 9. Subtract 5 from both sides. Negative 4n equals 4. Divide by negative 4. N equals negative 1. Subtract 5. Negative 9 and negative 5 make negative 14. Divide by negative 4. And n equals, well, 2 goes into both of those, so that would be 7 halves. So 4. The next ones are similar. For problem 2, it's just that they have inequalities. So we'll do one of them. We'll do 2a, and it's the same exact step. So we've got absolute value of 2b minus 4 greater than 10. So the same thing, meaning we're going to do our positive and negative side. The only difference is on our negative side we reverse our inequality symbol. So our positive side would be 2b minus 4 greater than 10, and our negative side 2b minus 4 less than negative 10. Notice what we're doing with those inequality symbols. So we're going to add 4 to both sides. 2b is greater than 14, divide by 2, b is greater than 7, and our steps are still going to be the same. Add 4, 2b is less than negative 6, divide by 2, and b is less than negative 3. So now when we graph this, our numbers are negative 3 and 7. At negative 3, we're less than negative 3, so that's open circle going to the left. At 7, we're greater than 7, so that's open circle going to the right, so we write or in. And because it's an or statement, we don't need to rewrite anything. We can just keep that as our answer. And notice how this starts off. When there's nothing outside, so nothing on either side of our absolute value symbol, and we start off where we're eating the absolute value that's on the left, it's always going to make an or. So notice down here how that's an or inequality. But if we start off and we're open to the right, it will make an and inequality. So let's pick one of those out. Right here, I. 2i says 9 times the absolute value of 2x plus 7 plus 1 is less than 28. And see the difference between the inequalities? This one's open to the right, and our one on 2a was open to the left. So watch what happens. So we want to get rid of the 9 and the 1. We need to get rid of the 1 first because it's addition. So we'll subtract it. We've got 9 times the absolute value of 2x plus 7 is less than 29. Actually, we're subtracting. That makes 27. There we go. That looks a lot better. And now how do we get rid of the 9? By dividing. So we get the absolute value of 2x plus 7 is less than 3. There. So our positive side, 2x plus 7, less than 3. Our negative side, 2x plus 7, greater than negative 3. And some of you guys might be able to see how we're setting up an and inequality right here. So we're going to subtract 7. 2x is less than negative 4, divide by 2, x is less than negative 2. Same steps on the other side. Subtract 7. 2x is greater than negative 10. Divide by 2. X is greater than negative 5. So now let's look at the graph of this problem here. So if we were to graph this right there, our numbers are negative 5 and negative 2 if we wrote them in order on the number line. If we look at the negative 5 between the x and the negative 5, we're eating the x, so that means we're greater than negative 5, so that's going to go to the right. And if we look at the 2, or the negative 2, we're eating the negative 2, so that means we're less than. So when a graph goes in on itself, that's an AND equation. I'd read this graph as all real numbers greater than negative 5 and less than negative 2. Well, I need to rewrite this as an inequality then. So that would be negative 5, negative 2, x in the middle. We're greater than negative 5, so we're going to eat the variable. We're less than negative 2, so we're going to eat the number. And that would be our proper inequality and graph for I. J would be the same. H is the same as M from homework 16 and M from homework 17, the same kind of stuff. So that's enough homework, and that was homework 17 for you guys.